So we have to give the modulated waveform. For the envelope detector, we have to give the modulated waveform. Then envelope detector contains one diode, resistor, capacitor, and after capacitor we will get the demodulated waveform, this yellow color. And this RS is very low value, source resistance very small value to avoid some noise, etc. It is very less value, so it is optional. RS is optional. So I will connect only diode RLC. Okay. So this VI is nothing but modulated waveform. At this point we are getting the modulated waveform. So from here I have to connect the envelope detector. From here I have to connect envelope detector, for which I need one diode, one resistor, one capacitor. Resistor, I will change it vertical. Capacitor, both of them to be parallel. Select the resistor, control R, it becomes vertical. Select capacitor, control R. Now I will do the connections. I have to connect from this output point. I am giving input to the envelope detector. This portion is envelope detector. And they are connected to the common ground. Same ground point, I can connect them. Only 3 elements, demodulation is completed. Only 3 elements, demodulation is completed. Okay. Now I will change this probe. I will drag and put this probe over here. This is the demodulated point. After capacitor, I am going to get the demodulation. Now, now analysis setup for proper visibility. The time you take it as 50 millisecond. Output will come for any time, but in the proper visibility, okay, 0 to 50 demodulation can be seen properly. And now simulate. Analysis setup, I am giving 0 millisecond to 50 millisecond. Now you can see here, this is the demodulated signal. Just 1 minute. Yes, values I didn't change. Okay, the resistor value, it is 10K. I didn't give the value for resistor capacitor, so I didn't get the proper output. 10K is the resistor value. Capacitor value 0.9 U. U means micro. 10K and 0.9 micro. These are the values. 10K resistor, 0.9 micro. Analysis setup 0 millisecond to 50 millisecond. Now if I simulate, you can see here demodulated sine wave is there. Demodulated sine wave. You can see the amplitude, it is completely positive side at 11 volts. Completely positive side at 11 volts. And this is the waveform. You can see blue color is the actual original message signal. It is on both sides. But the demodulated will look like a sine wave. But it is charging, discharging of the capacitor. It will be on the one side of the, only on the positive side. So similarly, we are getting the sinusoidal on the positive side. Okay. So this is about demodulated. And if I check, if I put one more probe, input and this is the message signal at the head of message. I am putting one probe at the head of message. I want to see the message, okay, original input and the demodulated together. Now when I simulate, 0 to 50 millisecond only. This is the original message. You can see this is the original message. It is going on both sides. Positive, above 0, below 0. It is proper sine wave. Okay. So in the waveform also I showed you. So you can see the blue color. It is on both sides, positive side and negative side. Okay. But yellow color, it is only on one side. This is the waveform, yellow color. Its frequency is different, so that proper sine wave is not visible. Okay, this is the demodulated. It is only on the one side, around 11. When I shown it separately, okay, we are able to see it as sine wave at around 11 volts. So the same waveform only here. Okay, at around 11 volts, same waveform only here. I will show you how it looks like a sine waveform. Okay, what I will do, I will just zoom the axis. I want to see from 11 to 12 volts. So what about this red color waveform alone? Okay. So for that, what I will do, right click, settings, y-axis, user defined. Okay, right click, settings, y-axis, user defined. Here I don't want the y-axis from -4. I will take from +11 to +12. Okay, now only red color waveform you will be able to see. You see only red color waveform. It is sine wave only because we are seeing both at a time. Their frequency different, so time period different. One waveform is looking clearly. Okay, it is giving clear picture. Other waveform was not proper. Other waveform was not proper. So when I zoomed it, user defined y-axis, I am putting 11 to 12. That waveform also sine wave only, but on one side. Okay. So similarly, you can get it back. You can get it back somewhere here. Plot, axis settings, y-axis. Okay. User defined. You put back the -4 y-axis from -4 to +12. Okay. Now both the waveforms are back. Okay. This is the message signal modulator input, and this is the output of demodulated signal. Both should look alike. Both should be sine waveform only. Okay, you can see both are sine waveforms only, but yellow color is in one side. Yellow color is the output of demodulator. Blue color is the input of modulator, not this VI. Input of modulator message signal. Okay, so with this demodulation, AM demodulation completed.